and welcome to Lecture 9.1, Paired Data in Graphing Ordered Pairs. So when we mean by paired data in graphing ordered pairs, we're going to start talking about our data in terms of how we can look at it visually and how we can interpret data visually. So let's talk about parts of a graph. So when we look at a typical graph, or aka chart, we're going to be talking about primarily line graphs, but this can also hold firm for scatter diagrams and bar and column graphs, which we'll show you in just a second. So typically we have a line that runs up and down a vertical axis, and then we also have one that goes to left and right, and that is our horizontal axis. And in the area, the blank area is our chart area, and this is where our data is kept. So here's what I mean by a column chart. The data is represented into columns, and it's paired data because each of these columns represents something horizontally in nature and as well as vertically in nature. So maybe this is the number of pairs. So this would be the column for pairs, and then the height would represent the number of pairs sold at a market maybe. Maybe this is the column for apples, and this is the number of apples that were sold that day. And these are the number of kiwis that were sold that day. So just by looking at the chart, we can figure out, okay, which one did we sell the most of, which would be the apples, which one did we sell the least of, so we can visually look at our data and grab some information from it. A scatter plot, or a scatter diagram, is just the data points plotted in points. So it just shows us kind of where our data is. And again, on the horizontal axis as well as the vertical axis, there would be some more information there to let us know, does it deal with time? Does it deal with number? Does it deal with quantity? Does it deal with age? Whatever it might be, those two axes would be labeled. And the plots that are in the scatter plot represent something along the horizontal axis as well as the vertical axis. And we'll talk about that more. A line graph is just like a scatter plot, but now the dots are connected. Literally, that's all it is you connect the dots in between. Why do we connect the dots in between? Well, for two reasons. One, it can show us how each of the dots are literally connected. Was there growth? Was there bigger growth? Was there more growth? Oh, there was a decline. So instead of just trying to figure out where these dots are in relationship to one another, we can see how they relate to each other. It also might show us a trend over time, what's happening over time. And the second, so that's kind of the trend over time and how they're connected is really one point. And then the second point is maybe it's not only just the points that are involved with our equation, maybe it's everything in between is also included. Well, a line chart would show us that. So it's maybe not just the two end points, but it's everything in between that we want to see as well. So those are two reasons why we would want to plot something on a number line or a scatter plot. Now we're used to working with data, and it's usually been one number, one variable, one value we find like an x. But we don't necessarily have to just think of them as one number. What if I have odd numbers and my odd values are 1, 3, 5, 7, 9? What I can do is I can assign them a position number. My first odd number is 1. My second odd number is 3. My third is 5. My fourth is 7. And my fifth is 9. So each one of these values might have a position that it is attributed to. Likewise, what if we think about the squares? My square values, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared 16, and 5 squared is 25. Now again, the 1, 2, 3, 4, 5 number is just a position number. It doesn't necessarily have to be the value that we squared. It just so happens to using this as a position number. In this lesson, we have quite a bit of terminology. We have some vocabulary that we need to get down because we're going to be talking about this and we want to use the right terms. First is the x and y coordinate. So a pair of numbers enclosed in a parentheses and it's separated by a comma is called an ordered pair of numbers. The first number in the pair is called the x coordinate of the ordered pair, and the second number is the y coordinate of the ordered pair. It's ordered because how we list it, always the x comes first and the y comes second. We do that so when I write a point, let's say 2, 3, that 2, 3 means the same thing to me as it does you and everybody else. So it is an ordered pair. The next thing we have is the Cartesian plane. It's also called the rectangular coordinate system, but most everybody just calls it the Cartesian plane. It's named after Rene Descartes. At least he's credited for it. And Rene Descartes was an amazing man. I didn't know him personally. He was well before my time. He was back in the late 1500s, early 1600s, and he wasn't a mathematician, actually. He was a philosopher, a French philosopher. And back in the day, we had two branches of mathematics that they didn't really see eye to eye, and they didn't really see a connection between the two. One of the branches was algebra, and the other branch was geometry. And they were completely separate. We didn't think that there was any overlap. Well, along comes Rene Descartes, and the philosopher that he was thinking about it, and he says, I don't know his exact words, but let's say he says, hey, can't I visually represent some algebra? And if I did that, I'd need some way of doing that. So Rene Descartes, who is also credited for the phrase of I think, therefore I am, he created this quadrant system. So there are 4 quadrants, right? So we have 2 lines that intersect. So one is completely vertical, that is the y-axis. We have one that is horizontal, that is the x-axis. And right where they cross, that's going to be our beginning point. So our beginning point is our origin. Okay. There's a whole bunch more information here, so I do want to run through it. In the top right-hand corner of our Cartesian plane is our Quadrant One. Quadrant meaning 4, so there's 4 parts to this. Our first quadrant. After our first quadrant, we start counting counterclockwise. Don't ask me why, we just do. So we move to the left, and it is Quadrant 2. Then we move down from Quadrant 2 to Quadrant 3, and then from Quadrant 3 we move to the right, and it is Quadrant 4. Now, it's very interesting, this Cartesian plane, because just because how we write our number, remember this is an ordered pair, we know if it is 2 positive numbers, let's say 2, 3, then that point lies in Quadrant 1. If the x value is negative and our y value is positive, then it's going to reside in Quadrant 2. If both of our values, our x and our y value, are both negative, then it's going to reside in Quadrant 3. And then finally, if our x is positive and our y is negative, then it's going to reside in Quadrant 4. If one of those values, the x value, is 0, it's going to lie on the y-axis. And if the y value is 0, it will lie on the x-axis. And we'll get more into this to plot points, but I'm just kind of running over it, and all of this will make sense in about 5 minutes. A little bit more terminology. An ordered pair is the grouping of the x-coordinate and the y-coordinate. Now the x-coordinate is the horizontal distance from the origin, and the y-coordinate is the vertical distance from the origin. And therefore our ordered pair, which is labeled as x, y, for generic, it's the x and the y value, is the intersection of the x coordinate and the y coordinate. So let's see an example. We want to graph these four ordered pairs. One is 3, 4. Next is 3, -4. Next is -3, 4. And the last is -3, -4. So for the first pair, this is how we do it. We start at the origin, and the x value is 3. So I move 3 in the positive direction. 1, 2, 3. And then from this point, my y value is 4, which is positive, so I move up 4. 1, 2, 3, 4. And that is my point 3, 4. Let's try it again with 3, -4. Again, always starting at the origin, I'm going to first move 3 in the positive direction of x. 1, 2, 3. And from here, I'm going to move -4 in the y direction. When it is a negative y, it is moving down. So I'm going to move 1, 2, 3, 4 down. And so my point right here is 3, -4. It's the intersection of 3 on the x and -4 on the y. That is the intersection. -3, 4. This time I'm going to start at origin, and because my x value is negative, I'm going to move to the left. 1, 2, 3. And my y value is positive, so I move up. 1, 2, 3, 4. And that is my point. The intersection of the y and the x coordinate is -3, 4. Now you can see, if I didn't read that number, the -3, -4, exactly as an x value and a y value, then my point would be different. If that -3 was the y, -3 is way down here. And if my 4 was the x, I would be over here at the 4. So you want to definitely make sure that the x value comes first, the y value comes last. Final point to plot on this graph, let's plot -3, -4, starting at the 0. Now, you could do the y value first. There's no rule that says you have to do the x value first, but it's a nice habit to get into. So I'm going to stick with my habit of doing the x value first, which is -3, meaning I move to the left 3, 1, 2, 3. And now my y coordinate is -4, so I move down 4, 1, 2, 3, 4. And I land on the intersection of -3 and -4. Now I've plotted several more points, so I want to quickly run through these. -1, 3. From the origin, we go 1 to the left and up 3. 1, 2, 3. So I'm at -1, 3. 2, 5. Starting at the origin, I move over 2, 1, 2 to the right and up 5, giving me 2, 5. Point 0, 0. I start at the origin and I move left and right, none. I stay there. Likewise, I move up and down, none. That means I stay there. So my origin is really 0, 0. It's named origin, but the point that belongs there is 0, 0. 0, 3, I start at the origin and I don't move left or right any, because I can move 0, but I move down 3. So there is 0, 3. And lastly, 4, 0, I start at the origin. I move to the right 4, but up and down none. So my point 4, 0 is right there on the x-axis at 4. So that's it for this lecture. Until next time, be seeing you.